How we do in AP Statistics. We're going to be starting part 2 of chapter 22, talking about confidence intervals, specifically the correct interpretation of them. This chapter, at least in the textbook and in some of the homework questions, hits this pretty hard, so let's get to it. Suppose the 90% confidence interval for the mean number of hours of sleep students get is that. So between about 6.3 to 7. Here's what this does mean. 90% of intervals that could be found using the same process, that is the same sample size, same z-star value, all things held equal as it were, would cover the true mean number of hours of sleep that students get. That's what a 90% confidence interval means. It means that if we were to do this process, we would be 90% certain that our interval works. 90% of intervals we would create using the method we use to get this interval are going to work, and that means 10% are not. Okay? So we just hope that this interval is one of the 90% that do rather than the 10% that don't. Here's what this also means. We can be 90% confident that the true mean amount of sleep students get is between 6.272 and 7.008 hours per night. We can be 90% confident that that is true. So let's talk about what this does not mean. It doesn't mean that 90% of all students sleep between about 6.3 and 7 hours per night. It also doesn't mean that we're 90% confident that a randomly selected student will sleep between about 6.3 and 7 hours per night. Now, what's wrong with these interpretations? These interpretations are wrong because the interval that we have is about the mean number of hours that all students sleep, not how many hours a group of students sleep or how many hours individuals sleep. This is a confidence interval for the population mean. This is the mean for the entire population. We are not talking about a group of the population, like 90% of the population, nor are we talking about randomly selected students. We're talking about the entire population. What is the mean for everyone? Not 90% of everyone, not randomly selected people within the group that is everyone. Here's another error that we could possibly make. 90% of all samples will have mean sleep between 6.3 and about 7 hours per night. Now, what's wrong with that? Well, here's the problem with this interpretation. The interpretation is wrong because confidence intervals make predictions about the population, not other theoretical samples. So we're talking about 90% of all samples. Well, confidence intervals don't talk about samples. They use samples, but they're not talking about samples. They're talking about the population. We use the sample to describe the population, not other theoretical samples that we could create. Unless we're sampling the entire population, which if we could, we wouldn't need statistics. So now we're going to proceed to the hypothesis test, a t-test for the population mean. This is a one-sample t-test for the population mean. As you could imagine, later on, we're going to talk about a two-sample t-test for the population mean, but here's a one-sample t-test. Just like with confidence intervals, when studying the population mean, we use the t-model, not the normal model. So researchers tested 150 farm-raised salmon for organic contaminants. They found the mean concentration of carcinogenic insecticide called Mirex to be 0.0913 parts per million, with standard deviation of that. As a safety recommendation to recreational fishers, the Environmental Protection Agency recommended screening value for Mirex is 0.08 parts per million. So Are farmed salmon contaminated beyond, that is a very important word, the level permitted by the EPA? So, what are the hypotheses we would use to test whether the salmon are contaminated beyond the level permitted by the EPA? Well, the hypotheses would look like this. The null hypothesis, the mean would be at our baseline of 0.08. And the alternative would be that it is strictly greater than 0.08. We don't care if it's less than 0.08. We're looking for extreme contamination. The assumptions and conditions to use the team model for a hypothesis test for the population mean are the same as the assumptions and conditions for a confidence interval, which we've already checked in our last video. Here are those conditions, the randomization and 10% condition to account for the independence assumption. And to make sure we can use the normal model, we need the nearly normal condition, which involves an analysis of our sample. And I guess it's good enough, just like last time. Now we're going to use t-test in the calculator, just like we used one proportion or two proportion z-test. Now we're going to use t-test, mean is implied, in the calculator to perform the one sample t-test for the population mean. We're going to find the p-value and interpret it in the context of the problem. Let's get to it. So check it out. We're here at the calculator. We're going to go to Stat. Going to go to tests. We're going to go down to t-test. All right. You will not ever use z-test in this class. We will always use t-test. Okay. Hit enter. And we're going to enter our mu0 value of 0.08, the sample mean of 0.0913, standard deviation of 0.0495. Our sample size is 150, and our alternative hypothesis is that the mean is greater than 0.08. We have checked all the boxes. Now time to hit calculate and find that p-value. The p-value is about 0.003. So let's interpret this p-value. We should reject the null hypothesis. There is significant evidence that the farmed salmon are, on average, remember we're studying the population mean, contaminated with Mirex beyond the level permitted by the EPA, namely above 0.08 parts per million. So here's another example of performing a one-sample t-test for the mean. A student surveyed other students at a small college in the Northeast U.S. and asked, among other things, how much they had slept the previous night. Here is a histogram and the data for 25 of the students selected at random from the survey. So let's get the conditions out of the way right now. The students were selected at random. That's good. 25 students is less than 10% of all students, I would assume, at this small college. And I guess that distribution is good enough. It's unimodal, I think, sorta. It's not really symmetric, but whatever. Is the mean amount that a college student sleeps at night at least as much as the 7-hour minimum recommended for adults? So we're going to test that hypothesis. So here are our hypotheses. The mean sleep is equal to 7 hours for the null, and the mean sleep is less than 7 hours for the alternative. We're testing to see, is this sleep for college students at this college on average less than that 7-hour mark? So those are our hypotheses, and now we're going to use the t-test in the calculator to perform the one sample t-test for the population mean. We have already checked the conditions. That's great. Now let's go to the calculator. So here we are at the calculator. I'm going to go to Stat. I'm going to go to Edit. And I've entered in my data into List 1 already because I value your time. So I'm now going to go to Stat and Tests, and I'm going to go to t-test. Remember, never z-test. We use t-test in AP Stat. And we're working with raw data. So we're going to click data. And then we're going to go to mu sub 0. That is going to be 7. It's the number in our hypotheses. Here's list 1. Leave that just as is. And we are testing the alternative hypothesis of the mean being less than 7 hours. So we want this one right here. And we're going to hit calculate. And there we have it. We would have a p-value of about 0.05, a little more than 5%. So how do we interpret our result? Since this is of the sociological nature, we can get away with some pretty high p-values, all right? We tend to work with high values of alpha, so sometimes what we normally could not get away with, maybe we'll have a bit more luck here. So, assuming alpha would be large for a study of this kind, which means we could get away with a high p-value, we reject the null hypothesis. There is significant evidence that the mean amount that college students sleep is less than the recommended minimum of 7 hours per night.